Hi, my name is Oran, and I'm the head of innovation in the HASC group, an advanced security center by EY. Today's demo is aimed at giving you an introduction into the application security world and also to the application penetration testing field. What is application penetration testing? It's basically a profession aimed at identifying vulnerabilities in business applications. Why is that something that organizations would even want? So organizations today deploy applications that are aimed at serving some specific business agenda, right? So they might be applications on the internet giving services to clients, or they might be applications that are deployed within their internal network aimed at giving services into employees that are a part of the organization. Either way, vulnerabilities within these applications can have significant repercussions. So if there's a banking application, for example, that allows me to transfer money from one account to another, it handles sensitive information, and if that information is compromised in some way, or if business processes are compromised in some way, I'm able to take advantage of it for financial gain, and eventually will cause some sort of financial harm, or it can also be a brand harm to the organization that I'm attacking. So there are many different attacks that we can start discussing, but instead of going through each and every one and what are the different repercussions, what we're going to do is just generally talk about two specific ones and show you what we can do with them. The reason is because it's not the amount of different vulnerabilities or attacks that are out there, but it's more about the fact that they all stem from the same origin, which is basically the tendency of developers to rely on expected user behavior. Okay? So what developers do is they create functional applications that are aimed at serving some purpose. One of the main issues is that they think in a very specific way, which is, what is the function that I'm here to serve and how do I do it in the best way? The problem is that they expect some specific behavior from a user, input some sort of logical process that they go through the application, and because they rely on it, when a user, which can be a malicious user, supplies some unexpected input, we can have unexpected repercussions in the application that can have some significance in the form of security. So what you see behind me is a demo application that is based on an actual banking app that was developed by some European bank, and it's based on the same source code and contains within it vulnerabilities that are similar to vulnerabilities that we identified in the real world. So today we're going to show you two different vulnerabilities. One is SQL injection, the other one is parameter tampering. Now let's see an example. First, let's have a look at this application. Every application that has some sort of a private section within the site usually has a login page, right? Let's go to the login page here. Even better, let's go to Internet Explorer, go to login. We're going to use for this demo two different types of users. One is a malicious one, and the other one is a naive one. The malicious one is called LeChuck, and that's going to be, it's all based on a computer game. LeChuck is going to be our attacker, and Elaine is going to be our victim. Okay? Let's log in with LeChuck. Username Le, password I'm not going to tell you. And let's log in. We can see how the application looks like in its private section. We can see that we can get an account summary, we can perform transfer and payments, we can see information about credit cards, and also brokerage. So far so good, right? Mm-hmm. So again, this application is destined to deal with users acting in a very specific expected way, such as there's a login screen and the user supplies username and password. So far so good. What happens when unexpected input starts getting into the picture? Let's see an example. So let's log out for a sec. We'll try to log in. Let's enter an invalid username and an invalid password and try to log in. We get username or password are incorrect. Please try again. So far so good. Again, this is an expected behavior when the username or the password are incorrect, and then the user needs to be notified about it. Now, let's make one small change and just add a quote somewhere within the input. Just a single quote. And try to log in. Suddenly we see there's an error. The application crashes. So this is already some sort of an indicator that something is wrong with the implementation of this specific mechanism. Now what I'm going to do is going to look a little weird. Just going to add some sort of a term. I'm going to add to the quote, or 1 equals 1, whatever input in the password, and log in. Suddenly I'm inside the application. Now I'm logged in, and as you can see, I'm logged in as a user called Guybrush. What just happened? So let's talk about it for a sec. The application has data or information that it saves in something called a repository or a database. Okay? In order to interact with the database, there's a very specific language that is used called SQL, Structured Query Language. Okay? So when an application has to deal with a user base, it saves the user base in that database. Now, when a user tries to log in, the application needs to check that the username and password combination are actually correct. How does it do it? It goes and queries the database and asks, is this combination correct or not? If it is, it allows you to log in and retrieves all the proper information for that account. If the combination is incorrect, you get an error message. Okay? So far, so good. The problem is when developers rely on unexpected behavior, when a user just inserts a combination of username and password. And then he or she, the developer, takes that information and they incorporate it within the SQL query that is sent to the database in order to get a response whether this has been right or wrong. The problem is that a malicious user can introduce SQL-based input into the query and manipulate the actual query sent to the database so that no matter what is sent to it, the response will be true. So what happens in the background is that an attacker inserts some SQL-based input. This is incorporated by the developer into the query going into the database, and then the response that is being received is true. So it allows you to log in. The thing is that the response is always true. So it's true for the first user in the database, and that is, in this specific case, Guybrush. So instead of being logged in as a certain user, we're logged in as the first user in the database, which is usually either an administrator or some sort of a temporary user, usually a high-privileged user. Now, this type of an attack is something that is based on it's an SQL injection attack, which is widely apparent in different applications today in the world. This specific manifest of this attack, or this specific vector, which is called login bypass, is, we'll say, pretty rare nowadays. Mostly because there's a lot of focus on this page because it's basically the gateway into the application. So the chances of somebody missing this as a main component that needs to be secured are probably more slim. So this is something that you might be able to find in different applications around the world, probably very low percentage. So this is a problem that used to be a major problem in the past. Today people are dealing with it in a much better way. Now let's go and see another part of the application and see how it allows us to get additional functionality. Let's sign off for a sec and go to branch information. What we can do here is search for different branches that belong to the bank. Okay? For example, let's search by city. And we know that there's a branch next to Oklahoma. We search and we see that we get all the branch information. The branch, the address, the city, everything is great so far. Now, if you remember, when we inserted a quote before, we got some sort of an error. Let's try it again, see what happens. Once we introduce a quote into the search, suddenly there's an exception. Apparently something is wrong. So now let's start exploring it. Basically what we're going to do is we're going to use SQL injection in a way that is called union-based SQL injection. So what we do here is we take a regular query that is used by the developer and we sort of piggyback ride on that query in order to perform an additional query that the developer did not intend to actually execute in the background. Okay? So what I want to do now is I want to map how many fields the developer actually extracts from the database. I can do this by, in SQL language, try to order by the amount of fields. So let's try order by 4. Select. We see that we still get everything properly. There's no exception. Everything works great. We try to order by 7, and again, everything is great. Now, if we try to order by 8 fields, suddenly there's an exception. So what I can know from this, the information that I gather, is that the developer in the background goes to the database and tries to extract 7 fields. Now what I want to do is use that information in order to construct an SQL query that will allow me to extract additional information over those 7 fields. Let's see an example. So I know that there are 7 fields being extracted in the background. So I'm going to perform a regular query for Oklahoma, finish that with a quote, and then add to that union select, and then 7 fields of type null. So far, so good. Now, I want to try and understand what type of database the application is using. One of the ways for me to check that is trying to extract information from a specific table. So if this database was an Oracle database, it has to have a table called all tables, which is a table that holds information about all the different tables in the database. Let's try and extract information from that. From select 7 nulls from all underscore tables. Try to select. We get an exception. The reason is because this table does not actually exist in the database, and that's because this is not an Oracle database in the background. This is specifically an SQL-based database. How can we prove that? Instead of selecting from all tables, we'll try selecting from a table that we know that exists in MS SQL, which is a table called sysObjects. Let's try and select. Union select from, I had a typo, from sysObjects. We see that the query is actually being executed properly. So now I have already information about what's happening in the background. First of all, the developer is using SQL in order to access the database, extract information, and the developer did not incorporate any security mechanisms within this process. So now I'm able to introduce SQL-based queries in order to extract additional information from the database. Now, the structure of the sysObjects table is something that is public. Microsoft has a database called MS SQL, and we know exactly its structure, the different tables and columns within it. So I know that each and every sysObjects table has a column called name, which is basically the name of all the different tables that are located within the database. So now what I'm going to do is, instead of selecting null, I'm going to change one of these nulls into name and select that from sysObjects. Let's select. Sorry, it needs to be a very specific field. There you go. Now you can see that we didn't just get information about the branch that we tried to look for, but we also got information about additional tables within the database. Okay? So if we go all the way down, you can see that we have different tables within the database that are called TBL accounts, TBL banks, TBL users, etc. Okay? Now that I have this information, I can start trying to extract sensitive information from these tables. Okay? One of the tables that seem the most sensitive to me, at least, is TBL users. It has information about all the different users within the database. Now, instead of I won't walk you through all the different steps in order to map it, but we can keep traversing through the database and extracting table information, column information, until we have the exact specific tables and columns that we need in order to perform a full extraction of all the different usernames and passwords. In the end, just to show you how it looks like, and usually things get really bad in demos, so hopefully it will work on the first try. What we'll do is, we'll try and extract name and password from TBL users. Let's select. Now what you can see is that as part of the query that we performed, which looks for a branch next to Oklahoma, we also get, as part of the union select that we've performed, we also get the list of all the different users in the database and their appropriate passwords. So again, we show you how we can manipulate you can manipulate existing processes that are being implemented by the developer and perform unexpected operations because the developer was expecting very specific input and was relying on that input in order to create some sort of a functionality.